Okay, so today I'm covering one of the many topics this week on trig. It's a lot to do in 1 week. And one of the things that you need to know, especially going on if you're in engineering and you'll be doing a lot of things with trig, you'll need to know how to solve equations that have trig functions in them, and you'll need to know how to solve them using the inverse trig functions. This is coming from section 5.3 in the text, and if you read through it, there's a lot that doesn't really get mentioned. One thing as I was going through, making this lesson, it's like there's things that it just assumes it doesn't really explain how you get certain answers. So I'm going to do my best to sort of explain how that all goes. Because if you're just relying on the book, it's not the clearest. So starting off, there's a lot of information that you need to have handy in order to solve using the inverse trig functions. So you need to have some knowledge of the unit circle and the values of the 6 common trig functions for the unit circle. So you have to know, okay, if my tangent is square root of 3, what values on the unit circle, what degrees or what angles will give me that value. So you need to have some knowledge of the unit circle and these 6 trig functions in relation to that. I'll get my slide to move. There we go. You also need to have some knowledge of the domain and the range of the 3 most common trig functions, sine, cosine, and tangent, as well as the period of these trig functions. The period helps determine when we're solving equations that have these trig functions, where on the unit circle are we looking for our answers. So for sine and cosine, basically anything between 0 and 2 pi on the unit circle, that's where we're looking to have an answer, because our period is 2 pi. But for tangent, your primary answers when you're solving are going to be between 0 and pi. So it's because the period is pi and then it starts repeating after that. So you have to have some knowledge of the period and then sort of where we want to find the answers that we're looking for. So I made a chart here to kind of help. You're going to need to know trig identities, and these are the most helpful ones. Being able to rewrite cosecant, secant, and cotangent, knowing that tangent is sine over cosine, and then knowing the 3 identities coming from the Pythagorean theorem, that sine squared plus cosine squared is 1, 1 plus tangent squared equals secant squared, and 1 plus cotangent squared equals cosecant squared. The other trig identities don't show up as often and are not as important. Now, the other thing that you need to know is these are inverse trig functions. So that means they cancel out a trig function. They're inverses, and the definition of an inverse function is that they undo. And so if you're going to get basically X out. So we use for inverses arc sine, arc cosine, and arc tan to indicate the inverse function. I have a video just kind of talking about the inverse functions in general. We also use the notation with a -1. So, and the order of these don't matter, but we are basically going to be doing inverses, using the inverses of existing functions. So whether you write it using arc or whether you use the -1, that is up to you. But you basically need to know that because these are inverses, the inverse in the trig function, they cancel and you're left with just your input value X. And again, we need to think about the domain, the range, and the period. So inverse functions are where you have your x and your y reversed. So the domain and the range for your inverse trig functions are reversed from your regular trig functions. And what's most important here is the domain, because when we're solving, we need to make sure that whatever we're plugging into the inverse is allowed to be plugged into the inverse, is that domain. So you need to kind of know what that domain is. And then again, we need to know, okay, our output, what is the interval of interest that we're looking for? The key thing is we are solving for angles. So our output is going to be an angle here. So this is just best done via example. That is just the best way to kind of do this. So I've got tangent x plus the square root of 3 equals 0. And we're going to solve this two different ways. One, just using the unit circle, and then one using the inverse trig functions. And you will get the same answer either way. I think one method is easier than the other, which I personally, they're both hard because you have to do some thinking. Trig functions, you have to do a lot of thinking, or at least have your stuff handy. I think using the unit circle is a little bit easier than the inverse trig function for something like this, but when you start getting into more complicated equations, doing the inverse trig functions are probably more helpful. So first off, if we were solving this with the unit circle, so let's just start with what we've got. We've got the tangent of x, oops, not equal, plus, no, it looks like a star, plus the square root of 3 equals 0. And so we want to get tangent by itself. And this is the same step whether you're solving by the unit circle or you're solving by the inverse trig function. So I'm going to just kind of do both of these at the same time because it's the same step. So you're going to subtract the square root of 3 from both sides, because we want to get that trig function by itself. And so we get the tangent of x equals negative square root of 3. So that's the same spot for each of these. So the way that this works when you're solving the unit circle is then you think of yourself, okay, tangent is sine over cosine. And we have this equal to negative square root of 3. And you can kind of make that a fraction. And so you're saying, okay, where is my sine equal to negative square root of 3? Where is my cosine equal to 1? And then you kind of go back to the unit circle. Now, when you're solving things with tangent, it's a lot harder in the unit circle because the unit circle, basically, the ordered pairs are giving you sine and cosine. They're not giving you tangent. So you have to just kind of think of this in terms of the fraction. So there is no spot where you just see square root of 3 and 1. That doesn't happen on the unit circle here. But everything that we do see the square root of 3 with is divided by 2. So if we go back, we're really looking for where do we have the negative square root of 3 divided by 2 over 1 divided by 2. The divided by 2's cancel out. And so it would cancel out and you would end up with negative square root of 3 over 1. So you're looking for one of the angles that has square root of 3 over 2 and 1/2. Now that negative could be with the negative square root of 3 over 2, or it could be with the 1/2. So the negative could be on top or the bottom. And so we're looking at two locations here, two locations, two ordered pairs. And the negative could be with either one. So you go back to your unit circle And so we are looking for, and I'm going to highlight here, we're looking for where we have the y value to be negative square root of 3 over 2, the x value 1/2. So that's the first one right here. That is 5 pi over 3. Or you may have the negative with 1/2 and then the positive with square root of 3 over 2. So that's over here. And that's with 2 pi over 3. So we have two possible answers for our angle. So this tells us, and I'm kind of running out of room here. Maybe I should rewrite this like this. So I just have some room here. So our angle X is either going to be 5 pi over 3 or 2 pi over 3, or it could be both. Now we need to think about the domain of tangent. What values are you allowed to plug into tangent? We're looking for where are we interested? Where is our interval where we're interested? So I'm going to go back to, actually we can, let's see, we can go here. Let's actually go back to this one. I think this one will be better. So for tangent, we're looking for answers. Our domain for X is negative pi over 2 to pi over 2. And our interval of interest when solving, that's the important part here, is from 0 to pi. So whatever answers we pick from X, we want them to be between 0 and pi. That's the interval that we're kind of interested in when we're solving here from the period. And then you can get other answers from there. So 5 pi over 3 is outside of that interval. 2 pi over 3 is the only value that is between 0 and pi. So that is our value that we're interested. That is basically our solution. But when we write our solution, because of the period and because of the fact that the circle kind of repeats, you can have multiples of this. And so the period of tangent is pi. So you add on to this pi times n to kind of keep it in that area of interest. And so there are infinite solutions to a problem like this if we just keep adding pi because of the fact that it's got periodicity. So that's how you solve this using the unit circle. So the inverse trig function, you still kind of have to use the unit circle, but you're also basically using your calculator. So what we do is we are taking the inverse tangent on both sides, or arctan on both sides. So you have arctan of tangent of x and arctan of negative square root of 3. So the arctan and the tangent cancel out because they are inverses. So we're just left with x. And then you have your arctan of negative square root of 3. When you're doing it this way, you need to make sure whatever you're plugging into arctan is in the domain of arctan. So that's where we go to this chart where I highlighted the domain. So the domain of the inverse tangent, or arctan, is negative infinity to positive infinity. So we can plug anything into that. So this is in our domain. This is okay. So now what I do is your calculator has the inverse trig functions, and the calculator usually uses the -1 notation. So you'll see tangent to the -1. That's your arctan. And so you're going to put this in your calculator. You can put it in radian mode or degree mode. My calculator that I am using, I have the TI-30X. when I put it in radian mode, it gives me the decimal approximation. And I don't know how many radians that is. So I usually have mine in degree mode and then convert it to radians, because all of our answers here, we want our answers in radians. But if you have a more advanced calculator that gives you the value in radians with pi, then you'll just keep it in radians. But my calculator doesn't do that. So I'm in degree mode. So when I am in degree mode, I just type in the inverse tangent, and then I type in negative square root of 3. And it will give me in degrees, I get 60 degrees, which then I need to convert, or I get negative 60 degrees. I can't forget my negative. Which then I need to convert to radians, and that's going to be a negative pi over 3. Now, we want our answer to be between 0 and pi. That's if I go back, that's when we have this arctan, the inverse tangent. That's our interval of interest when we're solving. So I need again go back to my unit circle. And I say, okay, where is my negative pi over 3? And so that is 5 pi over 3. That's the lower right quarter that I've, highlighted here. But then we also need to figure out, okay, what other values would give me that same, what are equivalent to that? And the period of tangent is pi. So when you add pi, you get 2 pi over 3. And we get back to that other value. So the 5 pi over 3, or the negative pi over 3, is not in our interval of interest 0 to pi for tangent. So we need tangent to be 0 to pi. But the period is pi, so if I add pi to negative pi over 3, that will get me my 2/3 or 2/3 pi, or 2 pi over 3, and that is the answer that we're interested in. So essentially what you're doing here is you're kind of adding pi, that period there, so that it's in the right spot that you're interested in. And so that gives you 2 pi over 3. And then you're just cycling through. So you're adding pi n to it. So you get the same answer. But notice that if you do this using the unit circle, you're getting, okay, 2 pi over 3 or 5 pi over 3 gives me that value of tangent. When you do it with your inverse trig function, it's giving you only one possible answer, negative pi over 3, which is, it is the reference angle. So note that your calculator always gives you the reference angle. So that's why it gives us negative pi over 3 versus 5 pi over 3. And then you need to go back again and think, okay, where do I want my answer for tangent? We want it between 0 and pi. So then you have to go back and kind of figure out, okay, what is the other answer that falls into that area? So that is, that's a weird thing to me. That's why I think the unit circle part is easier, because I can see easily on the unit circle, okay, yes, there are 2 places that give me a tangent of negative square root of 3. Using the calculator, it just gives me one answer, and it kind of, you have to do some thinking to kind of think about what that means. And I think it's less intuitive, but you get the same answer in the end. So here we're going to solve something. We've got cosine, sine, and tangent, and we just want all answers that are in the interval 0 to 2 pi. So what that means is if you're given a specific interval instead of doing the plus pi times n, you literally write all the answers that fall between that interval. So we have to actually, add in that period to figure out all those answers. So you have to decide here, are you solving for cosine, sine, or tangent? And then whichever one you decide to solve for, you need to rewrite the others so that you've got everything in there. So if you decide to solve for cosine, you need to turn everything else so it's in terms of cosine. If you're solving for sine, you need to make everything in terms of sine. You want to do it in such a way that you only have one trig function. So I know that tangent is sine over cosine, so I can rewrite that, and then I only have two trig functions, sine or cosine. And then from there, I'm going to just kind of see, okay, what would make sense as far as my simplifying so that I can get to a single trig function. So my first step is just to use the definition of tangent. So I have cosine of x plus sine of x, and then I'm going to multiply that by sine of x over cosine x, because that's what tangent is equal to. And then I can simplify that. Sine of x times sine of x is sine squared x. So this is going to be cosine of x plus sine squared x over cosine x equals 2. Now I've got cosine in two places, so it makes more sense to change the sine to cosine and let things cancel. So we're going to use the identity sine squared plus cosine squared equals 1. So sine squared is equal to 1 minus cosine squared. So I'm going to rewrite that. So I have cosine of x plus 1 minus cosine squared x over cosine x equals 2. Now these are over cosine x. There's a trick where you can combine this fraction. So I can have 1 over cosine x minus and then cosine squared x over cosine x. So I'm splitting that fraction up. I'm undoing the combining fractions. This allows us the cosine squared x over cosine x. We can cancel this out. So I have cosine x plus 1 over cosine x minus, I was about to write a plus, it's a minus cosine x equals 2. This cosine squared over cosine, one of the cosines cancel, and then you're just left with the cosine x. So now notice that if we're trying to combine this, that we have a cosine x and we have a minus cosine x. So those are going to cancel out and we're going to be just left with 1 over cosine x equals 2. So I'm just going to go to another slide here. I have 1 over cosine x equals 2. But we want cosine x, we don't want 1 over. So you can take the reciprocal of both sides, and that will give you cosine of x equals 1 over 2. So now at this point, now that you've gotten to this point, you can solve by going back to the unit circle and say, well, what values of x give me a cosine of 1/2, which I personally think is the easiest method to do. Or you can solve by doing inverses. So we'll kind of do both here just to kind of demonstrate here. There are places where you have to use the inverse, and that's when it's not on the unit circle. So for example, the last question on the application assignment, you're not going to get something that is on the unit circle. So you have to solve it using the inverse, and you're going to get a decimal for your degrees, and that's fine. And when you get something like that, you don't try to find other answers on the unit circle. Just stick with that one answer. You don't need to do the whole multiple answers thing. But here, 1/2, we know that's on the unit circle. So I'm going to go back to my unit circle. I'm looking for where is my cosine, which is my x on the unit circle, equal to 1/2. So I'm going to erase my tangent stuff here. And I'll just use a different color. So we've got cosine of 1/2 here at 5 pi over 3. And cosine of 1/2 here at pi over 3. So we have two possible answers, 5 pi over 3 and pi over 3. Oops. So x can be 5 pi over 3, and x can be pi over 3. Now, when we're trying to figure out where is our interval of interest here for cosine, we want between 0 and 2 pi. So both of these answers are between 0 and 2 pi. And it's specified here, we wanted all solutions in the interval 0 and 2 pi. So that means that these are both solutions. So we usually, if we have more than one solution, we'll write it combined, pi over 3 and 5 pi over 3. Now, if you were to solve this using inverses, you're going to take the inverse cosine of both sides. And that cancels out the cosine. And then you have the inverse cosine or arc cosine of 1/2. But we need to make sure we can put 1/2 into there. So you go back and you're looking at your domain of your inverse cosine or your arc cosine. As long as you're plugging in a number between -1 and 1, you're okay. So we're good there. Whoops, wrong problem. And then you're going to go on your calculator, use your inverse cosine of 1/2. And again, I'm in degree mode just because it's a lot easier for me. And this gives me 60 degrees, which in radians is pi over 3. So then you have to think about, okay, where other values does that show up on the unit circle? Because if you're just looking at here, you're like, okay, well, there's only one answer. It's pi over 3, because that's what your calculator gives you. It gives you the principal or the reference angle. It doesn't give you if there's multiple angles. So again, you have to kind of think about, okay, what other angles will give me a cosine of 1/2? Because you have to think about, what did I plug in here? And so then again, you're going back to your unit circle. And in this case, we have a difference of, we're not at like a pi or anything like that. You know, it's not like with the tangent, just kind of add pi and that gave you your other value. We've got a difference here of how many why am I doing that? Can't think of the math here. I don't know why I'm having a brain freeze. 120 degrees. Because I'm like, why can't I think of this here? So we've got a difference of 120 degrees between these two possible angles. And so it's not, you know, it's not something that you can even kind of think about and be like, oh, cosine, I need to add 120 degrees to get to my other potential value. Or if you think of it going the other direction, we need to go back this way. So we are adding I believe the 240 degrees to get to the other value. Yeah, 240 degrees. Again, it's kind of weird to get that. So you just have to kind of think about, okay, well, you know, if I solve using inverse cosine, it gives me one answer. Now I have to kind of think about, well, what other possible answers do I get there? And the nice thing about if you're solving for inverses for like sine and cosine, you're looking at like at least for cosine, you're looking at the x values. So you're basically looking at, okay, between, you know, what other vertically matches. And then when you're doing this with sine, you're kind of looking at horizontally, what other horizontally matches. If you do enough of these, you can kind of see the pattern. But I like to just, I just prefer using the unit circle method because I think it's a little more obvious that there's more than one answer versus when you use a calculator because it just gives you one. Oops, I don't know why I went there. So we have to kind of go back to the unit circle to get our other value. So you get pi over 3 and 5 pi over 3. And if you're looking at the textbook, it will give these other values. It doesn't really explain how it gives that the other values and how to find it. It's basically kind of go look at your unit circle. Or if you have a table of common trig values, you can look at that and then you can see where else do I get 1/2. So here I've got a problem with tangent and secant in here. So we have tangent squared equals secant of x minus 1. And so you need to choose, do I want to solve this in terms of secant? Or do I want to solve it in terms of tangent? So secant is 1 over cosine. So if I try to rewrite secant, I'm just going to get cosine and tangent. And I still have two different trig functions. But we do have a trig identity with tangent that converts to secant. So if I use that trig identity, I can either convert if I had secant squared, I could convert it to tangent, but I don't. But I do have tangent squared, so I can convert that to secant squared, and then I've got only secant in my problem. So that's what we're going to use. We're going to use this other trig identity. So our trig identity that we're using here is 1 plus tangent squared of x equals secant squared of x. Or if you're solving for tangent squared, that's secant squared x minus 1. So instead of, well, I'm going to just start. We have tangent squared x equals secant x minus 1. And instead of writing tangent squared, I'm going to replace that with secant squared x minus 1. And then the equals secant of x minus 1. So first thing I notice here is that if I add 1 to both sides, the constants just cancel out. And so I have secant squared x equals secant of x. You cannot divide both sides by secant of x because it's possible that the secant of x is 0 and then we're dividing by 0. So generally, when we're solving, we don't divide both sides by something with x, unless you know for sure that x is never 0. We don't know that. So instead, we need to subtract secant of x from both sides, and we're going to get something that's quadratic in form that we can kind of factor. So this gives me secant squared x minus secant of x equals 0. And I can factor out secant of x. And that gives me secant of x minus 1. So now when you've got something that's factored and you're solving, you set each factor equal to 0. That's what you do when you factor with quadratics. So we have secant of x equals 0. And then we have secant of x minus 1 equals 0. So you end up with two different problems, two different things that we're now solving for x. So the secant of x equals 0. If you are, what helps me is because I don't have like secant memorized for the unit circle. You know, I'm looking at that, I'm like, well, what is secant? So I rewrite it as 1 over cosine of x, because that helps me. But I'm going to just rewrite what we had here. So that was a big gap. And then we had secant x minus 1 equals 0. So secant is 1 over cosine of x. So that's 1 over cosine of x equals 0. And while you can't divide both sides by something with x, you can multiply both sides by something with x. That's okay, because you can multiply by 0. So I'm going to multiply both sides by cosine of x. And what will happen here is that they cancel and you end up with 1 equals 0. So this gives us no actual solution from that particular equation. There is no place where the secant of x equals 0 in that, because you get 1 equals 0, that's false. So then we move to the other equation here. So I'm going to add 1 to both sides, and I get secant of x equals 1. So again, just because it's easier for me, I rewrite secant of cosine. So I get 1 over cosine x equals 1. And I can do the same trick, multiply both sides by the cosine of x, and you end up with 1 equals cosine x. So now if you do this with like your unit circle, you're asking yourself, okay, what values, what angles give me a cosine of 1? If you are doing with this with arc sine, or I mean with our inverse trig functions, we would take the arc cosine of both sides. So I'm going to do that first, just to kind of change it up. Because that's what we're doing here, solving by trig functions or inverse trig functions. So you get the arc cosine of 1 equals x, because the inverse cosine and cosine, those cancel out. And I prefer to write arc cosine versus cosine to the -1, just because usually that -1 exponent makes people think you're doing 1 over, because a negative exponent is a reciprocal when you have things with x. So I don't like to get that confused. So that's why I write arc cosine instead, just so that it's you don't accidentally think you're doing 1 over. So we'll pull out our calculator for this. And so you're just taking the inverse cosine of 1 and you get 0. You're going to get 0 whether you're in radians or degrees, but you get 0. So you get 0 is equal to x. So that would be 0 radians or 0 degrees. So we go to our unit circle, because we need to also check, are there other solutions? So we are right here. And so we were, if I go back to our problem, wondering, well, where is our cosine equals 1? And cosine is essentially x on the unit circle. So you're like, okay, where else on the unit circle do I have x equals 1? And that there's only one location. There is only one location where you can get x equals 1 on the unit circle. So this has only one answer here. And so it's just 0. We don't usually write 2 pi, and that is because we want our answer 0 to 2 pi, but we're not including 2 pi. So if you're going to use 0 over 2 pi when you're looking at your output here. So we get only one answer, x equals 0. So now I've got one more example here. You can see these kind of take a while. You have to do some thinking here. The good thing is that most of the engineering like problems that you have involving trig functions, they don't normally come out at nice, are nice angles. And so you don't normally have to find multiple solutions. You just need to find the one that your calculator gives you. So that's a benefit for going forward. But this is math, so we want to find all of the solutions. And so this doesn't say that it's on a specified interval. So if it doesn't specify, you're going to do the plus period times n deal. So we've got sine squared of x equals 3 times the cosine squared of x. So you have a choice. Do we want to rewrite cosine in terms of sine, or do we want to rewrite sine in terms of cosine? And you'll get the same answer either way. I'm going to choose to rewrite cosine in terms of sine so that you have an example of using the inverse sine. Just so that way we saw using the inverse tangent, we saw inverse cosine. So let's do an example with inverse sine. So let's convert the cosine to sine. So we're going to use the identity sine squared x plus cosine squared x equals 1. So cosine squared x is 1 minus sine squared x when you solve that. So I'm going to replace cosine squared x with 1 minus sine squared x. And now we have only sine in here, so we want to get those together. And first I need to distribute the 3. So I have sine squared x equals 3 minus 3 sine squared x. So I'm going to add 3 sine squared x to both sides to collect my sine squareds together. And that gives us 4 sine squared x equals 3. So now you're going to divide both sides by 4 because we just want sine squared x. And so that's going to be equal to 3/4. Now we're solving just for sine. So if you've got it squared, you take the square root of both sides. So you're going to take the square root of sine squared x and then the square root of 3/4. So this will give you sine of x equals the square root of 3, and then square root of 4 is 2. So it's going to give you square root of 3/2. So if we solve this using our inverse sine, you take the arc sine on both sides. So the arc sine of x equals the arc sine of square root of 3/2. Arc sine and sine cancel. So we get x equals arc sine of square root of 3/2. And I just realized that I forgot, when you take the square root, you get a plus or minus. So we've got plus or minus square root of 3/2. So we have 2 that we're looking here at. We have x equals arc sine of the positive square root of 3/2. And then we have x equals arc sine negative square root of 3/2. It's very easy to forget. You take square roots when you're solving, you get plus or minus. So you do get 2 possible answers here. So if we throw these into our calculator, so I'm going to do the inverse sine of square root of 3. Oops, I hit the wrong button. Divided by 2. So that gives me 60 degrees. Oops, what is going on here? There we go. I don't know why it was like writing and then disappearing. Let's try that again. 60 degrees. And then if I do negative square root of 3 over 2, I get negative 60 degrees, which is negative pi over 3. So I have positive pi over 3 and negative pi over 3. And we want our answers generally between 0 and 2 pi. This is a situation where they're not restricting us to that value. So you would have like your plus pi n thing, but we don't normally use the negative for our reference angles. When you're writing your answers, we want it to use the positive. And so to figure out if we've got negative pi over 3, that you add 2 pi, and that is equal to 5 pi over 3. So really, we've got two possible answers here. We've got pi over 3, 5 pi over 3. But we have to think about the unit circle. What other answers are there? Because basically, our calculators are only giving us the reference angles. So we're essentially only between negative pi over 2 and pi over 2. That's what your calculator is giving your answers, your output at. And it kind of makes sense because if you go back here, our range for arc sine is between negative pi over 2 and pi over 2. So your calculator is going to output an answer within that range, only that range. And then you need to figure out, well, what other values fit this? Because it's, that's specifically what your calculator is going to give you. With the tangent, it's interesting though, because the calculator gave us a negative 60, which is not in the range from 0 to pi. I think the calculator just kind of defaults to that quadrant 1 and quadrant 4. I actually tried to look on my calculator to see if it told me. I looked at the manual and it did not say specifically where on the unit circle it's outputting your answers. So I think it's just doing negative pi over 2 to pi over 2 for all of these, doing that initial kind of reference angle thing. But anyway, so problem we have at hand. So we've got pi over 3, 5 pi over 3. And let's think about going back. We've got our arc sine, and we're looking for what angle gives us, if I go back, a sine of square root of 3 over 2 or a sine of negative square root of 3 over 2. So sine is essentially the y value when you're looking at the unit circle. So we're looking for positive square root of 3 over 2 and negative square root of 3 over 2. So I'm going back to my unit circle. And I'm going to just kind of switch colors again here. So we already know pi over 3. That's a positive square root of 3 over 2. And we had 5 pi over 3, the negative square root of 3 over 2 right there. But there are other places on the unit circle because we also have 4 pi over 3. And then we also have 2 pi over 3. So what we do here is we've got these 4 possible answers on the unit circle. If the problem was restricted between 0 and 2 pi, you would list only these 4 answers. But our problem didn't necessarily specify that, so we want to do the plus. The period here is let me go back. The period is essentially 2 pi for a for sine, cosine. But if we look at our answers here, we can actually use a shorter period. Because if we notice, it's 90 degrees to go from here to here, and then 90 degrees to go from here to here. Between the narrow angles, that's not, like if it was 90 degrees or 45, it might be really nice, but it's not, it's 60 degrees. I suppose you could do a period of 60 degrees, but then we've got 60 degrees in here, but then we've got 120 degrees there. So it's not a nice pattern. So we're going to have 2 different patterns here, both with adding pi to get to the other values. So if I add pi again here, that gets me back on my unit circle. So we're going to have one where we start at pi over 3, and then we add pi, and that will bring us to this answer. And then because we don't like to use the negative version, like negative pi over 3, we're going to start at 2 pi over 3 instead of the 5 pi over 3 part. And we're going to add pi to get to the other possible answer on the unit circle. So we're going to have two different equations we're writing here, essentially to show the periodicity. So I've got, I'll just do that in my blue here. So the first one that we had with our pi over 3, so we've got pi over 3, oops. And then we're adding pi times n, and so each multiple pi will get us to another answer. So that would give us to the 4 pi over 3 that we found was a possible answer. And then here, you've got that negative pi over 3. If you add a pi to that, that gives you your 2 pi over 3 to start with. And then we add pi, and that gets us to our 5 pi over 3. And then that kind of cycles through. So even though the period of sine is 2 pi, if we had essentially, because we have multiple answers here, we have to kind of think about the pattern, and then you have to think about, well, what are we looking for on our unit circle? What other answers work? And so our period sort of gets cut in half because of these multiple answers that work. You know, there's multiple places on the unit circle where our angle in this case is, or our output is square root of 3 over 2. So there's multiple angles where that happens. And then we also have the negative square root of 3 over 2. So this is, you know, this is how you solve using inverse trig functions. You can use your calculator to get you at least the starting point to give you the angle that you start with and then go from there. But either way, you end up having to look at the unit circle, which is why that I generally just use the unit circle method to find all of my possible answers versus doing the inverse trig function. The only time I really use the inverse trig function is if I know that it's going to be like the first answer that I get on the calculator is the right answer, or if it's like a real world situation. Generally, it tends to be, your answer tends to be in quadrant 1 or quadrant 2. And you tend to get answers that aren't like on the unit circle nice like this. And so then I'll use my calculator, because if it's not on the unit circle, if I had like 1/5, if I was trying to find the arc sine of 1/5, well, that's not on my unit circle. I have to do that on my calculator to figure out, and that comes to 11.54 degrees. You know, there are some situations where you have to kind of do that. But if it is something that lands on the unit circle, I think it's a lot easier to just use the unit circle to get the answer. So, I mean, hopefully this didn't confuse you too much. If you go to the reading doesn't really explain how they came up with these other answers. They just kind of do it, even in their examples. So it's kind of, you're always going back to the unit circle, and it's like, there's, you know, I try to find little tricks, but it's like not every trick works. I can't say, oh, sine is always going to be this way or that way or whatever, because, you know, I can't say, well, if we go back to our two cosine ones, this one, to get the other answers, we basically had to add 4 pi over 3 to, you know, add 4 pi over 3, we get that other answer, because your calculator only gave you pi over 3. So 4 pi over 3 is kind of weird thing to add, but you can do that. But then we had cosine in another situation, in this problem, where you didn't do that because there's only one possible. So there's not even a little trick that I can say, use your inverse trig function and then always add this to get your other value. It doesn't work that way. You always have to go back to the unit circle and kind of look at what's happening, and then look at your other answers and try to make it work. So fortunately, I don't have a shortcut for that, but hopefully I've at least showed you the different situations of different types of inverse trig functions, and you have an understanding now that your calculator gives you only one answer and then what to do after that. So if you have questions, let me know. Hopefully I don't have any, I made sure, you know, I did these problems before to make sure I don't have any typos, since I did have an error in one of my videos where I missed a negative. So I've made sure that I double checked all my work. I shouldn't have any issues with that this time, but if you do find something, let me know so I can double check and make sure it's not a typo or Rido or whatever. So thank you, and I will see you guys later. Bye.